Hello, Internet. Today we're going to discuss how to uh, solve the retina maze problem using the backtracking algorithm. Okay, so in this problem, we will be given a 2 cross 2 matrix, uh, integer typed matrix. The elements will be 0 and 1. The 0 will indicate the invalid paths, and 1 will indicate the valid paths. Okay. Also, we will be given the starting point and ending point. The mouse will be left in the starting point, and he has to find its way to the finishing point. Okay. So this is the algorithm, but I think I'm going to write everything else from the beginning again to show you guys how it's done. So I'm just going to back things up. Just a minute. Control X, Control V. Okay, and the main function here. Wait. Oh. So from here to right. Okay. So first things first. Oh, and one more thing. I'm doing this in the object-oriented style. So that's why the main function and the maze class they're in separate Java classes. Okay. So let's begin. So first things first, we need to create a 2D matrix. Okay. So int maze. Oh. Int x naught, y naught, xf, yf, int I, okay, int n. So for now, let's just say we have these elements. Now let's write the constructor. Maze oops, sorry, these are yes, I think that's right. So n to n. I'm simply initializing all the variables in this class, okay? All the private elements in this class. Okay. So we have the dimensions of the, of this maze, the starting point where the mouse will be left, and the finishing point where the mouse will go is the destination of the mouse. Okay. Now that we have these elements, let's just create the maze. Maze equals to new int okay. So that's it, I think. Now we need a Boolean function. Now we need a Boolean function which will tell us if a box is safe, if the next next box is safe or not for the mice to go. So Boolean if x is greater than 0 and equals to 0, x is less than n, and y is greater than or equals to 0 and y is less than n. Okay, and finally maze x y is equal 1, return true, else return false. Right. After that, we are going to create a function, and that function is going to give us the backtracking solution of this problem. So I think I'm going to take a void typed function, void say move. Right. Now we're going to have to print in all the paths of this problem. You see, when I was testing this thing the last time, for this particular input, the mouse is in the 0, 0 position, and it has to go to the 4, 3. That's 0, 1, 2. Here, the mouse is going to follow these paths. It can have 15 paths, and I'm going to print all these paths. Okay. So for that, we need another element, string case, and in order to print this 1, 2, 3 stuffs, I'm going to take another integer I, or maybe count. Right. So let's just initialize them. Case equals to empty string, and you see there might be a case where there will be no possible solution. So for that, I'm going to take a Boolean variable, Boolean b, and initialize it to false. We'll see what these things do in this move function. So okay, the way I'm thinking this, it will be guaranteed that x and y is already in the path. Okay, so I'm going to include it in this path. For that, you'll see what I'm doing. I'm doing. S1, S2, S1 equals to jar dot to string x. S2 equals to dot to string y. Okay, so s equals to s plus comma okay, it's just plus s1 plus comma plus s2 plus comma, and yes, I think that's it. Now, first, the default case. If we have arrived at the destination, print this path. Okay. If we arrive, for that, we write this following code segment. If x is equal xf and y is equal yf, system dot out dot println s. That's going to print the entire path. Oh, I almost forgot. Okay, we need to keep a backup of this s. Okay. Now, if and also set this b equals to false. Sorry, true. Yeah, this b. This b is going to help us to determine whether the algorithm has found out any paths or not. Okay, so b equals to true, or else, right. Else we're going to, if is safe x y plus 1 move x y plus 1. Oh, I almost forgot, we have only two valid moves in this case. Okay, the mouse can either go horizontally or go down vertically. Okay, these are the only two possible moves. If you want to have a more complex code, a more complex version of this problem, you can add go up and go right, go down, go. Here I'll show you. Yeah, in this website, this is the source and this is the destination, and they have taken the horizontal and vertical moves, or just the left and down moves, valid. If you want, or for any complex problem, you have to add other cases. So let's get back. If is safe x plus 1 y I prefer keeping things aligned. Move x plus 1 y. Oh. Right. Okay. Right. Oh, I was. What's that? Backup S. Okay. When this code is going to go in this if, the S string is going to get changed. So we may find path or we may not find a path. For that, the s will be changed. So after this s comes out of this if statement and a code executes this third if statement, it is going to start the s from where it left. I mean, say this is the path 1 for this following code. Last time when I had run it, so the first path is this one. When our code is going to go in this second if statement, instead of writing a new path, it's going to add from here. So that will be an invalid path. That is why we need to import the backup of this s and then run the move function or move method. Yes. So s equals to backup s and then move. Into C. Similarly, we need to keep a backup. We need to bring the backup of s, initialize the s again, and Viola. I think we're done here. Right. So let's run back to the main function. And n x naught, y naught, xf, yf. After that, scanner s equals to new scanner system.in system out println please enter all these things respectively. After that, s dot next integer, Control C, x naught, y naught, y sub 0, x sub 0, y sub 0, xf, yf. Okay, now that we know the dimension, the starting position and the ending position, we can take a maze typed object. So maze typed object m goes to new maze n x sub 0, y sub 0, x sub f, y sub f. Yeah, that's right. After that, we have to run this move 0 0. Oh, hold on. Okay. Next, we have to run m dot move x naught, y naught, and that is going to print all the paths. But in case, oh, I almost forgot. Silly me. We need to create the maze. Okay. So for int I equals to 0, I less than n, I plus plus. For int j equals to 0, j is less than n, j plus plus. n equals to s dot next id. And just for simplicity, I'm keeping this public, this maze array public. Okay, so m dot maze I j equals to n. So we're going to take the input. After that, we started that's we need to display a message to the console which will say now enter the maze. You know what I mean. Okay, not exactly maze elements. Yeah, that's much better. After that, we take the input. Next, we initialize the move function with this. Now, if there's a path, we're gonna get paths like this. But if there's nothing, there will be no display. There will be nothing like this. So let's just display a message to the console. If m dot here the b comes into play, equal to false, system out println no solution is possible. And that's a crying emoticon. Okay, I think we're ready to go. So let's run this thing. Okay, let's give a simple example. Say, let's give this one. Okay, so input will be 1 0. Okay, so first thing, 4, x naught is 0 0, and in this case is 0 1 2 3, so 3 3. Now enter the maze elements. So 1 0 0 0. Oh, I forgot. This, what the? 1 0 0 0. 1 1 0 0 0 1 0 0 0 1 1 1. And so 0 0 0 0 1 0, that's 1 0, 1 1 1 1 2 1 3 1 3 2 3 3, and that's the code. That's the solution. And I forgot one last thing. Here, let's just display a message. Path okay, so what's that? Yes, count equals to 1, and then count plus plus. That's going to display how many paths we have. Okay, so let's run again. Say this time we'll make the maze a little bit of complicated. Okay, so 4 0 0 3 3. So 1 1 1 1 1 0 0 1 1 1 0 1. Say 1 1 1 1. There are 3 paths. So the first one is 0 0 0 1 0 2 0 3. So we're traveling this way. After that 0 1 3 2 3 3 3. That is 1 3 2 3 3 3. Path 2 is 0 0 1 0 2 0 0 0 1 0 2 0 2 1 3 1 3 2 3 3, and the final path is 0 0 2 0 3 0. So the final path is we go all the way vertically downwards, then take a sharp right and go this way, and finally we reach this 3 3 position. So that is the rat in a maze problem, solving rat in a maze problem using backtracking. Thank you for watching. I hope you enjoyed the video. Best of luck. Happy coding.